in this problem, we are going to find the separation of solid mixture using hydraulic classifier. So let us read the problem. In a mixture of quartz of specific gravity 2.65 and galena of specific gravity 7.5, the size of the particles ranges from 0.0052 cm to 0.0025 cm. On separation in a hydraulic classifier using water as the medium, under free settling streamline conditions, three fractions are obtained. One consisting of only quartz, one of only galena, and one a mixture of quartz and galena. What are the ranges of particle sizes in centimeter of the two substances in the mixture portion? In the mixture of quartz and galena, we need to find what is the minimum size of quartz and maximum size of quartz. Likewise, minimum size of galena and maximum size of galena. Of course, already it is mentioned that it is settling under streamline conditions, but still we will check whether this Stokes law is still applicable. So what we are going to do, we are going to find the maximum settling velocity corresponding to the maximum diameter and maximum density particle, which is nothing but the galena, which is the size of that particle is taken as 0.0025. There is a maximum size particle we have. So for galena, specific gravity is 7.5 and water 1. So we are getting this. Of course, this is from specific gravity to density difference we have converted, and 18 mu is that of water, and upon substituting everything, we are getting this velocity to be 0.00221 meter per second, and calculating this Reynolds number particle, which is 0.0025. There is a maximum diameter, and velocity, the maximum velocity, which is 0.00221 already estimated, and density of the fluid and viscosity of the fluid, so which is found to be 0.055, which is lesser than the acceptable Stokes law regime of Reynolds number particle of 0.1. So otherwise the entire particle will be settling only in the Stokes law regime, because the maximum particle itself is obeying this Stokes law. Then everything below that will definitely obey this Stokes law. And from Stokes law we have this Vt is proportional to d square. Where is it? Vt is proportional to d square for a given density. So for a given particle, we are simply plotting this Vt relation, which is a like y equal to x square relation, and we know these sizes 0.00052 and 0.0025. There is a minimum and maximum size of the quartz galena feed we have, and what we are doing, simply for this diameter, that is a maximum diameter, simply make a vertical line, and like that for the minimum diameter also make a vertical line. So these vertical lines give these two important points. So otherwise what we are going to do, we are going to find the velocity corresponding to the maximum size of quartz and velocity corresponding to the minimum size of galena. So minimum size of galena and quartz is actually 0.0052, that is this point, and maximum of maximum size is 0.0025, and maximum velocity we are going to find. Otherwise, using this diameter and density of quartz, we can find this velocity. Likewise, using this dimension and that of the galena density, we can find this velocity. Once these two velocities are obtained, then we can now easily separate this mixture by operating at this velocity, what is called as the maximum velocity corresponding to, or is a velocity corresponding to maximum size of the quartz. If you operate at this velocity, what will happen? The galena, which is having still higher settling velocity, what will do? This galena will be simply settling, and all the other things, these size materials will be simply floating. Not this size, we will be having a pure galena settling corresponding to this size range, which is this size to this maximum size. So we will be having this galena, this pure galena as pure galena, and if we operate at this minimum velocity corresponding to this Vt minimum, if you operate at velocity corresponding to VT minimum of galena, what will happen? Now only this portion, which is nothing but now only we have only quartz alone. Quartz of size range from 0.00052 to this dimension will simply only quartz alone will be remaining in the fluid. All the other things are this portion would be simply settling. So already we are separating this pure galena by operating at this velocity, and we can, by operating at this velocity, we'll be getting pure quartz. And what is there in the mixture of quartz and galena only, which is not possible to separate using this hydraulic classifier, is this thing. Otherwise, what is it? The galena of 0.00052 to this dimension, and quartz of this dimension to 0.0025. Otherwise, this size ranges. Otherwise, this quartz of sorry, we are not yet to find this dimension. This quartz and this this galena and this quartz have the same settling velocity, so you cannot separate in this operating region. Or in this region, if you try to operate at any velocity, you will be getting definitely quartz and galena. Whereas if you operate at this velocity, this only pure galena will be settling from this size to this size. Whereas if you operate at this velocity, we will be having pure quartz of size 0.00052 to this size. So we are going to find the dimension of this one and this one. Okay, that's a task now. So what we are going to do, already we know we need to find the velocity of maximum sized quartz particle. So what we are going to do, so this we know the dimension, and we know the this rho p minus rho, which is 2650 minus 1000, and dimension is 0.0025, and viscosity, density, viscosity, these are all already known to us. So this is the velocity we are getting, velocity corresponding to this line. Now using that velocity we are getting diameter. So this diameter, what is the need for this thing? We are getting this dimension. So that dimension is coming to be 0.00126 meter. So otherwise this dimension is now known. The another thing is, to be correctly, this dimension is known. So now we need to find this dimension. For that, what we have to do, we have to use the velocity corresponding to the minimum sized galena particle. This dimension is known and this density is known. This also corresponds to this velocity. This velocity is this line. So using that we get the maximum size of quartz in the minimum size of quartz in the galena quartz mixture. Okay. So for that, again making use of the Stokes law formula, Vt minimum corresponding to Vt corresponding to minimum of galena particles, minimum sized galena particles. Okay, 0.00052, and this is again rho p minus rho is 7500 minus 1000, which is 6500, 9.812, and 18 mu. So we have 0.96 into 10 power minus 4 meter per second. Substituting the velocity again in this Stokes law, we are getting this diameter, which is coming to be equal to of course we are getting the diameter of quartz. Otherwise, this in the formula again we are simply substituting density of the quartz. Why it is? Because we are finding this dimension, this point. For this point we are using the density of the quartz. That's why we are using this density of quartz, and difference which is rho p minus rho, that's why 1000. Now we have this dimension to be 0.00103 centimeter. Okay, now we have done with the problem. So we have first we have obtained this velocity, and from which we have this dimension which is nothing but 0.00126. So otherwise we have this pure galena starting from 0.00126 to 0.0025, and pure quartz corresponding to this 0.00052 to 0.00103. Okay, and the mixture which is not separable using this hydraulic fluid, which is water, is starting from, where is quartz starting from this velocity, or is this line is quartz. So 0.00103 to 0.0025, or is this size of quartz and this size of galena have the same settling velocity range. So we cannot say by operating at any velocity we cannot get pure quartz and galena. But by operating at this point we are having pure galena, and operating at this velocity we have pure quartz. So that is the idea of this hydraulic classifier. This mixture of quartz and galena, quartz starting from 0.0, or is from this size to this size, and galena from this size to this size. That's why. Okay, fine. So what is to be filled in the answers? The minimum size quartz, so this is your minimum size, and the maximum size quartz in the mixture is 0.0025, and for the galena in the inseparable mixture, which is this point, which is 0.00052, and the maximum corresponds to this one. Okay, this is the mixture of quartz and galena in the mixed portion. Okay, what is called as these portions. Okay, it's a nice problem. To again summarize this diagram, what we have drawn, this diagram, how we have drawn, Vt is proportional to d square. So that's how we have this nice relation curves, and we know the size dimensions 0.00052 to 0.0025 centimeter, and we are going to find this point and this point. What is it? This point and this point. That will give you the two dimensions. What is it? This corresponds to this, and this gives this. So these two dimensions are estimated, which is 0.00103 and 0.00126, and we have this portion to be pure galena, and this corresponds to pure quartz, and this range corresponds to mixture. So they are obtained. Okay, with this we are done with our problem. Thank you.